So to find a limit from the graph is a relatively simple process. We need to look at what value of x the limit is approaching. So in A, we have that x is approaching 0. So what that means is we go to 0 on the x-axis and we look from both sides. So from the left and from the right, what y value or what height is that function approaching? It's approaching a value of 1, so that limit is 1. In B, now we're looking at 3 on the x-axis, so as we're approaching 3 on the x-axis, where's the y value of that function approaching? It's approaching 0. Likewise with C, x is approaching -1, the height of that function is approaching 2. Now, these next two examples provide a bit of a complication. If we take a look at D, as x is approaching -2, from the left and from the right, it appears that the function is approaching a height of 3. But we have a hole in the graph right there. The hole in the graph simply means that the function isn't defined at 3, but with a limit, we don't actually care if the function is defined or not. We only care what the function is approaching. So as x approaches -2, the height of the function is approaching 3. So yes, we can have a limit where there is no value of the function. Likewise, as x approaches 2, from the left and from the right, it appears that the function is approaching -2. But as we get exactly at 2 on the x-axis, we have this point above. That point above has no impact on the limit. All we care about is the actual graph of the function itself. So as x approaches 2, the function is approaching -2. Last one, f, x approaches -3. This one we have no special circumstances. The height of that function is approaching 2.